As an extension to the binomial theorem or binomial expansion, we may ask you to find a specific term in a binomial expansion. So we're going to go through that using still Pascal's triangular combinations, but we just want to look at an individual term rather than expand the whole thing. So we're going to start with the example from 10-140, where Andrew has to expand a plus b to the ninth. You know how to do that now with Pascal's triangles or combinations to find those coefficients, and then we just have the ascending or descending exponents for a and b. So he just realized that he didn't have the coefficient for a cubed b to the sixth. So he starts writing out the 9 rows of Pascal's triangle, 1, 1, 1, 2, 1, 1, 3, 3, 1, and that's going to take forever. So his friend Robbie says, well, you can find that just using combinations. And that's what we'd like you to get to. It's not like Pascal's triangle is wrong. If you have it on hand, great. But if you have to build it every time, it's kind of annoying. So what combination should Andrew use, and what is the coefficient? So if I just look at this expansion, you're going to have a to the ninth plus a to the eighth, b to the seventh, so on and so forth, plus a to the seventh, b to the, well, that should just be the b to the first, and then b to the second. Now what we want to think about is the combination of certain values. Remember, this was 9, choose 9. This one was 9, choose 8. So the relationship that we want to really harp on is that whatever we're choosing is the exponent of the a value. So if I go ahead and keep going, I know then the coefficient of a cubed b to the sixth is going to be 9, choose 3. And then it's going to be a to the third, b to the sixth. I didn't show it in the last video, but if you need the help for the combinations on a calculator, it looks like this, that we're going to have math, we're going to go over to probability, and we're going to go to number 3, which is NCR. So I'm going to do 9, choose 3, which in this case is 84. So you're going to have an 84 a cubed b to the sixth. And depending on what a and b are, that might change, and that's what we're going to look at ahead here. So in 10-141, again, they may not give us what term it is, so we have to be able to find out what the exponents are going to be. So an important piece is asking, well, how many terms are in this expansion? So luckily I had this from the previous video of a plus b to the 11th, that if you notice, there's not 11 terms. We have to get over that we have these zeroth terms or constants, so that there are actually 12 terms. So when they say, what's the 5th term in the expansion, this problem they gave me, oh, that's the a to the 7th, b to the 4th term. They won't always give you that, and that's a good thing. Well, because we want to be able to know what combination we're actually finding. But let's look at this pattern. I know that if I expand this, it's going to be a to the 11th, and then plus this combination, a to the 10th, b, plus a to the 9th, b squared, plus a to the 8th, b cubed. That's 1, 2, 3, 4. So if you want to, you could just write it out. That wouldn't be the worst thing ever. But maybe there's a little bit faster way if they ask me what's the 8th, 9th, 10th term to find that. So we can use the exponents to help us out. I know that's going to be x to the 11th, so I have to find 5 terms past that, or 4 terms past that, sorry. So what I can do is I can take the exponent, and what I mean by exponent is the exponent of the expansion. It's going to be x to the 11th, and then subtract the term that you want to find. Okay, I want to find the 5th term, but if you notice that, I'm going to actually have to add 1 because that first term does count, and when I subtract it, it's not counting that first term. So if I take my exponent of 11, I subtract, I want to find the 5th term, and I want to add 1. That's going to find me the exponent of my a value. So in this case, 11 minus 5 plus 1 is 7. 11 minus 5 is 6 plus 1. So I know it's going to be the a to the 7th, b, these two have to add to 11 again, b to the 4th, and that will help me find which combination I need to choose. So this one is going to be 11, choose 7. These two have to link up, and these have to add to 11. Now I already have that. In this case, it's 330. You can do that in your calculator as well. So I'm going to have 330, a to the 7th, b to the 4th. Okay, so I found that coefficient. Now look at part C. They just add on 1 extra piece here. It says now Rebecca needs to know the 5th term. of x minus 2 to the 11th. So instead of just a plus b, they have an x and a negative 2. So how can you use the result for part B? We'll just substitute those in. This is kind of the step-by-step. Got to find which combination, put it in a plus b or a and b form, and then just substitute. So we have 330. My a now is x, so it's just x to the 7th. And then I'm going to have b, which is negative 2 to the 4th. So if I go to my calculator, that's going to be 330. I think I actually have it above. So let's just go up to there. That's this step right here, which eventually is 5280. So I have 5280 x to the 7th. All right, moving on. Let's just have one if it's got two things for a and b. Write out all those terms. So it says, what's the 7th term of 2x plus 3 to the 8th? So what I want to find first is what is my coefficient of a, or sorry, well, both coefficient of a and exponent of a, and then what term goes with that. So in this case, I'm going to take my exponent 8, I'm going to subtract 7, and then add that 1. That's always an add 1. It doesn't change based on what these are. So I know then 8 minus 7 is 1 plus 1. I'm going to be finding the a squared term, and then the b, since it's got to add to 8, is b to the 6th. That also helps me figure out my coefficient, which is going to be the combination of that step, which is going to be 8 choose 2, because it's going to be the exponent of that piece right there. So I'm going to do that in my calculator. 8 choose 2, again, is right here. I pressed math, went over to probability. 8 choose 2 is 28. But in this case, my a now is 2x in parentheses. That's the number one mistake. Put it in parentheses. And then my b value is 3, so I'm going to take 3 to the 6th. So I get 28. This is times 4x squared times 3 to the 6th. So I'm just multiplying all those coefficients and those constants, which is right here. So I get an 81648. 81648x squared. So as you can see, we can have you find individual terms that might help expanding the whole thing, but it's not, don't be above just expanding it. Finding those terms and finding those patterns is a deeper understanding of what's going on to find these individual ones. So hopefully that helps out, finding those individual terms.